Just a moment. Roll number 1, Onishka Agarwal.
Present, sir.
Okay. 2, Joydeep.
Present, sir.
3, Revati.
Present, sir.
4, Oyon.
Yes, sir.
5, Joya.
Yes, sir.
6, Rohit Kumar.
Yes, sir.
7, Adrita. 8, Kaushani.
Present, sir.
9, Muktika.
Present, sir.
Right. 10, Spandan.
Present, sir.
11, Shaumo. 12, Choirik.
Present, sir.
13, Megha.
Present, sir.
14, Trihil.
Present, sir.
15, Alia.
Present, sir.
16, Srijoni. 17, Rajoshi.
Present, sir.
18, Aniket. 19, Shumit. Roll number 19, Shumit. 20, Alok Kumar. Roll number 20, Alok Kumar Jha. Roll number 21, Sumit Kumar Jha. Roll number 22, Pogda.
Present, sir.
23, Onesha
Present,
Coyle.
sir.
24,
Present, sir.
Anjali.
Yes, sir.
25, Nirmalo.
Present, sir.
26, Prashant. 27, Rahul. 28, Ritesh Kumar.
Yes, sir.
29, Shouresh.
Present, sir.
30, Arijit.
Yes, sir.
30, Arijit.
Yes, sir.
31, Rajlakshmi.
Present, sir.
32, Shubhoshi.
Yes, sir.
33, Rajat.
Yes, sir.
34, Kanishta.
Yes, sir.
35, Shomodeep.
Present, sir.
36, Orko Nondi. Orko.
Sir,
So
I'm
my roll number is
36.
37.
Sir,
Huh?
Sahil.
What's your roll number?
36.
36, Sahil.
Yes, sir. Sahil Malik.
And what's the roll number? 37, Orko.
Yes, sir.
Just a moment. One moment. 36. Just a moment. 36. Okay. 36, Sahil. Sahil Malik. Okay. Just a moment. Okay, fine. Then actually 37 Orko Nandi, isn't it? Just a minute. 37 Orkonandi. Is it so?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
Right. Then 38 Dheeraj.
Present,
Is it
sir.
so?
Dheeraj, present, sir.
Right. Then 39 Vishal.
Rishabh.
39 Rishabh, isn't it? Okay, fine. Just a
Yes,
moment.
sir.
Okay, just a moment. Just okay. Then 40 Vishal Pandey.
Sir.
Right. 41 Numan.
Yes, sir.
42 Aniruddha.
Yes, sir.
43 Shoikot. 43 Shoikot. 44 Satikant Poddar.
Sir,
44.
46, sir.
Huh?
46, sir.
Okay, Satik 46.
Yes, sir. Roll number change, sir.
Then what about 44? 44 who is?
Sir, 44, I don't know, sir. 45 is Sakat, sir.
45 Shoikot.
Yes, sir.
Then after 42 Aniruddha Paroi, is it so? 42.
Yes, sir.
Then in between 43, 44, 45. And Shoikot, what's the roll number yours? Shoikot 46. Hello?
No, sir. Satik 46, sir. My roll number is 46.
Shatik, isn't it? Shoikot
Yes,
45.
Yes, sir.
Okay. Just a moment. Actually, so many changes are there, so naturally. Just a moment. And 45, Shoikot Pal, absent. 46, Shatik, present.
Present.
47, Lakaraman,
Yes, sir.
Lakaraman, 47. Okay. Then 48, Amit Ranjan. 48, Amit Ranjan. 49, Farjan.
Present, sir.
I have to check all these actually. Then 50, Vishal.
Present, sir.
51, Projit.
Present, sir.
52, Siha.
Present, sir.
53, Harish Shadani.
Present, sir.
54, Sriyan Sahu.
Sir, I'm 55.
You are 55. Just a moment. Accordingly, I have to change. Just a moment. So 55, Sriyan Sahu. Okay.
Yeah.
56, Anupam.
Yes, sir.
57, Anand Sharma.
Sir, I am 58.
You are 58.
Sir, I am 57. Orijit Shil.
Or is it still 57? Okay, just a moment. Or is it still 57? Just a moment. Or is it still 57? Okay, right. Then 58, Ashish
Present,
Kumar.
Sir, 58 is Anand Sharma.
58 is Anand Sharma.
Yes, sir.
55, Shreyans, you have got the attendance. Then 57, Arijit, you have also got the attendance, isn't it?
Yes,
Okay.
sir.
And
Yes, sir.
58 is Anand Sharma.
Yes, sir. 58.
And what about the Ashish Kumar Sharma? Anand Sharma, 58. Okay, fine. That is one. Okay, fine. Then 59, Shottam Singh.
Sir,
59.
59 Ashish Kumar.
59, Ashish Kumar Sharma. Okay. Just a moment. '59 Ashish Sharma. Just a moment. '59 Ashish Kumar Sharma, isn't it? Okay. Ashish Kumar Sharma. Okay, fine. Then roll number 60.
Sir, present, sir.
Roll number 60. You are Anonna.
Yes, sir. I'm roll number 60.
Roll number 60, Anonna Shikdar. Okay, fine. Just a moment. Roll number 60, Anonna Shikdar. Okay, fine. Just a moment. Roll number 61. Roll number 61. 61 की Bharat Singh. Roll number 62. Roll number 62. Roll number 63. Hello, roll number 63. Roll number 64. Roll number 65.
Present, sir. 65 present.
65. Shobik Shur.
Yes, sir.
Okay. 65. Shobik Shur. Right. Then 66.
Present, sir.
66. Tushar Bash. Okay. I have to check all these actually. Then roll number 67.
Yes, sir.
Sri Krishna. Okay. And who is roll number 64? Anybody else? After 67, anybody else?
No, sir.
No, sir.
67 is
It
the
is
last.
last.
Up to 67, is it so?
Yes, sir.
Yes, sir.
Okay, fine. So anybody is there who hasn't got your attendance? Okay, I will just recheck. Today is the first day, so I am finding. So I have to check with the other roll list also. Okay. Anyway, so today is the first day. So as you know, you are having the environmental science, and so I am going to share the screen. Just a moment or so. Okay. I'm going to share the screen. Just a moment. This one. Just a moment. Any screen is visible? Hello?
Yes,
sir.
Yes.
Yes,
Here
sir.
you, huh?
Yes, sir. Visible.
So you find here the code structure, that is environmental science. The code is MC401. In fact, before I start your class, in fact, I had to send your assignment because I didn't have any other alternative. Okay, as you are having CA1, a very within a week we have to fill it up. So naturally, unless I understand something that you are responding with respect to the class, you will not be able to do, because last week actually that's the holiday. So naturally, you are having only one contact hour. So as you find here, as per curriculum, the course code MC401 and the course name Environmental Science, as you see that per week we are having one contact hour only. Okay, and the credit point is 1. Okay, is it understandable? Clear? Hello?
yes, sir.
Okay, fine.
Yes, sir.
Okay, so here you can see that as per Macau, the marks distribution, the examination scheme, you are finding here that credit point is 1 and you are having one contact hour per week or so. Naturally, if we somehow miss that class, so naturally it is going to be a very long gap. And however, as far as the syllabus is concerned, I would like to tell you that what we used to have earlier, the credit point nearly 3 for the environmental science, the entire syllabus, that the same syllabus actually you are going to study, and for that only the allotment of contact hour is only 1 hour. Naturally it's very difficult, as you understand. So you just see the mid-semester exam means that is actually on the basis of your internal exam, the 15 marks, and assignment and quiz 10 marks, and the attendance 5 marks. So altogether these three actually consist actually 30 marks as per as internal assessment, and 17 marks the end semester exam. And as per the 30 marks internal assessment, other than the 5 marks, you will find that the other 25 marks actually on the basis of CA1, CA2, CA3 and CA4. So naturally on the basis of interaction with you, generally we decide that what the allotment of the marks should be, the CA1 as per your any individual or student. And this is the content of the syllabus actually, it is the entire thing is there. I'm not going for that at this moment in detail. But I would like to tell you at least that what's the course objective and the course outcome also. Okay, that is very important from that point of view. Just try to follow this. Just a moment. This is the course outcome actually. Before I go for the course outcome, I would like to tell you quickly the what's our course objective. Just a moment. This is actually previous year. You can find the course file also. In fact, so you will find. You just look at here. This is the course objective. Whether this screen is visible? Hello?
Yes, sir.
Okay.
Yes, sir.
So naturally, the course objective means, as you understand, what we intend to study, what we intend to learn in terms of the environmental science. So that's why you find the course objective means the aim of this course is to teach students about current environmental problems, and from an environmental perspective, the student will learn how to apply various strategies to control, reduce and monitor all environmental problems that might cause huge adverse impact on environment. So once again I'm repeating, as far as the course objective is concerned, the aim of this course is to teach students about current environmental problems, and from an environmental perspective, the student will learn how to apply various strategies to control, reduce and monitor all environmental problems that might cause huge impact on the environment. Now, as far as the first thing is concerned, in terms of the course content for the lesson plan, you understand the topics to be covered, as I have already mentioned, the basic ideas of the environment, course objective, course outcome, and the text and reference books, and in terms of air pollution and control and water pollution and control. Then let us go quickly, actually, that is the course outcome. Okay, just a moment. You just see the course outcome. Course outcome means after studying the course, after studying the syllabus in a particular topic, what you are going to achieve, what you are going to means gain, and what will be its practical implication or application. because you are doing something. So naturally, instead you can expect that when you are learning something, when you are you object to study something or learn something. So for what purpose? Definitely you are going to achieve something. You are going to gain something. Okay, other than your degree, actually, that in terms of your practical aspect, you just see that after successfully completion of this course, student will be able to. Here we have made 6 outcome, and that is simply based on your curriculum, present curriculum and syllabus. So here you find the course outcome. They analyze the source of air pollution, water pollution, and suitable technology to monitor and control these types of pollution. So naturally, the Bloom level you will find the analyze. The number 2 actually is second course outcome. The course outcome 2, you can find the understand the concept of BOD for clean water bodies. Understand the concept of BOD for clean water bodies, analyze and interpretation of data of important water parameters. So that means that at least you have to understand that. BOD means biological oxygen given. So overall, you understand that what's the importance of our fresh water, clean water, or some pure water like that. Then course outcome 3, understand the crisis of availability of fresh water across the globe and possible solution for sustainable development. Because from a sustainable development point of view, you know the source of fresh water and pure water is very, very important to all of us, and how we can protect our environment, protect our water body, how we can reduce the environmental degradation and reduce the pollution overall on the environment, not only with respect to the water pollution as well. And then course outcome 4, you can find the understand the importance of ecosystem for levels of action, conservation of biodiversity and silent features of India's biodiversity. What does it mean? It means, suppose if we want to protect our environment, that means we can protect our ecosystem. For that, you need to protect our all this biotic system as well as abiotic system. So naturally, the water body, then the atmosphere, which we can make less polluted, then which we can protect our water bodies, we can protect our forest, etc. So naturally, you understand the importance of ecosystem for levels of action, conservation of biodiversity, and silent feature of India's biodiversity. And course outcome 5, and that also the understand level if you have the Bloom's level, because you are going to be basically the information technology, the IT software engineer. So naturally, at least you may not have the direct accessibility to these, but you know the application of the software is vast. In fact, all these environmental problems and these days actually control through the electronics, electrical, and the application of the computer science and information technology, as you know it very well. Then course outcome 5, you understand that analyze contemporary environmental issues like hazardous solid waste disposal and eco-friendly energy development such as solar energy and waste energy development to engage in lifelong learning. It is very, very important. That means how we can protect our land actually from solid waste pollution point of view. That means from the land pollution point of view. So naturally, there should be some methodically scientific technologically improved solid waste disposal management, and not only that, how we can not only we can reduce the solid waste pollution on the land, then by reducing it by incineration or by some other method, but also we are able to convert them into various types of fuel also. So therefore, you can understand how we can analyze the contemporary environmental issues like hazardous solid waste disposal and eco-friendly energy development such as solar energy and waste energy development to engage in lifelong learning. So naturally, Bloom's level is analyzed. And then you can find course outcome 6, that means you see they analyze the sources and impact of the noise pollution, because whenever we try to consider in terms of the environmental pollution, generally we focus on mainly the air pollution, water pollution, land pollution, and the protection of our ecosystem or ecology. But we forget about the noise pollution, because this is also having very, very adverse impact on the overall on the environment. So naturally, this is also equally important along with the other aspect from our sustainability point of view. So what is that? So that's course outcome 6 actually. Analyze the sources and impact of the noise pollution, and sustainable development for environmental friendly technology to prevent and control this type of pollution. And the Bloom's level you find analyze. Hello, is it clear? Hello,
Yes, sir.
this is audible.
Yes, sir.
Yes, sir.
And visible. Okay,
Yes,
fine,
sir.
fine. Okay, very good. Then quickly, if you look at this, for example, suppose the environment actually what surround us. Now what surround us means the naturally you are finding the living things surround us, okay, and as well as the non-living matter. So that's why you know the environment is broadly divided, actually the ecosystem, the under abiotic system, that is the non-living matter, another is biotic system, okay. So naturally the environment what surround us actually. And you will see the environmental science, and basically it is a multidisciplinary subject, okay, because it comprises the chemistry, biology, other basic science, mathematics, engineering, technology, economics. So naturally it is understandable that it is a multidisciplinary subject, okay. And when you try to understand the environment, generally we can divide, or we can classify the environment under four important segments. One, you are considering atmosphere. Actually, that is nothing but related to the air. Then you are finding lithosphere, nothing related to that is nothing but related to rock, soil, land. And then hydrosphere, it is nothing but related to water. All these we are talking about the what is present on our earth planet where we are living. And then you are finding biosphere, because you know the biosphere means living species, and which actually encompassing, actually you are finding the surrounding the atmosphere, lithosphere, and hydrosphere. In all these sphere the existence of the biosphere, okay. And therefore you understand that if we consider the main components of the environment, then you are finding atmosphere, which is related to air. That's why you are concerned about air pollution and control. Then second one, you are finding lithosphere, that is related to rock, soil, land. That's why you are so much concerned about land pollution and control, in particular in terms of the solid waste disposal management, and how we can convert that solid waste into various types of renewable eco-friendly fuel, energy, as you understand. Then hydrosphere, as you understand, it is nothing but in terms of the water, what is being present on the earth's surface. And that's why we are concerned about related to that, how we can have the sustainability point of how we can have sustainable the pure and fresh water from our survival point of view. And from that point of view, we are very much concerned about the water pollution and control, and how we can develop various types of sources of the water for fresh water. As you know, when I will explain the hydrosphere, what is that or so. And then you find that actually including all this atmosphere, lithosphere, and hydrosphere, there will be existence of the life, and that is called actually biosphere, living species. So naturally we will be concerned about the ecology, ecosystem, and biodiversity. So that's why you can find the four important segments of the environment: atmosphere, air pollution and control; lithosphere, land pollution and control; hydrosphere, water pollution and control; and biosphere, you find the ecology, ecosystem, food chain, food web, and in terms of the population growth control. And then you find in terms of biodiversity overall. Hello, is it clear?
Yes, sir.
Yes, sir.
Okay, very good.
Yes, sir.
Then we are going to actually share this one. So now, if we start with the atmosphere, so naturally, unless we know the atmospheric composition and structure, we will not be able to understand air pollution and control. You already sorry, you already know it very well. The atmosphere is nothing but it consists of actually dry air mixture. Why I'm saying that? Because dry air mixture one composition, that is and beside you will find there might be water vapor, another composition, and another you will find the presence of the suspended fine particles also. Okay, so therefore air pollution and control, under that we are going to study atmospheric composition and structure also. Then you can find here, that means you say the earth atmosphere is a thin layer of gas held around the surface by gravity. So what you are finding, the Earth atmosphere is a thin layer of gas held around the surface by gravity, and 90% of the atmosphere mass is within 15 kilometers of the Earth's surface. So you are finding 90% of the atmosphere mass is within 15 kilometers of the Earth's surface. Okay. Actually, I would say rather 70 to 80%. Basically, 90 to 90%. Actually, it is going to be within nearly 90% is going to be within 45 kilometers, and then the nearly 99% it is going to be within 90 kilometers in the atmosphere above the sea level. Okay. As you know, the Earth radius is about 6,400 kilometers, and the atmosphere is like, suppose if you consider the shape of the Earth planet is such that you can consider just like the atmosphere is a layer of paint. That means you are saying on a basketball. That means you are saying the atmosphere is nothing but is a thin layer of gas, which actually not only the dry air gaseous mixture like oxygen, nitrogen, etc., but also you will find along with water vapor and also along with the suspended particle, okay, which is covering or encompassing the Earth's surface also. Okay. Hello, it is visible, understandable, audible?
Yes, sir.
Okay, fine.
Yes, sir.
Then you see that you know it very well that without atmosphere, or not only the atmosphere is also there in Venus planet, but whether it is possible for us to survive there? No. So because in atmosphere you must have at least oxygen first of all, and secondly you must have water. So without atmosphere having the oxygen, and without hydrosphere having the fresh water, we cannot survive, or the sustainability of the life is not possible. Maybe to some extent the some microorganism, maybe to some extent, I would not say that it is ever possible. To some extent, here and there, through the existence of the microorganism, we try to find out the existence of the life on the other planet. Okay. But nevertheless, you understand, without atmosphere having oxygen and the hydrosphere with the fresh water, we cannot survive. So therefore, you see here, the atmosphere protects life on Earth by absorbing ultraviolet solar radiation. That the another part you will study when you will understand the stratospheric ozone layer. Actually, why it is so important and why we are so much concerned about the stratospheric ozone layer depletion. Then you can find that the atmosphere warming the surface through heat retention greenhouse effect, because without the natural phenomenon of the greenhouse greenhouse effect of atmosphere on this Earth planet, then the existence of the life would not have been possible. Because it is you might already know that without greenhouse effect, the Earth's surface temperature would have been near about -18 to -19 degrees Celsius. However, due to greenhouse effect, the actual Earth surface temperature or effective Earth surface temperature is generally +15 degrees Celsius. So therefore, you are finding the rise in surface temperature of this Earth planet to the extent of 33 to 34 degrees Celsius is possible by the natural phenomenon of the greenhouse effect. Otherwise, the existence of the life would not have been possible on Earth planet, and that's why we are looking for the existence of the living species on other planets. Okay. And here you see, however, we are concerned about the advanced greenhouse effect or enhanced greenhouse effect for excessive global warming. We are concerned about that. Okay, so that you will study later on. And then you can find not only that atmosphere balance, actually, you know, the in terms of the radiation of the Earth's surface, and also by absorbing the heat energy from the sun. In this way, you can find a reduced temperature extreme between day and night. As you know, is a diurnal temperature variation. Normally, or in general, you find on the daytime we are having the higher temperature than that of the night. It is very it is easily understandable. Then you can just imagine the mass of the atmosphere. You are finding it is about 5.15 into 10 to the power 18 kg, and that is actually due to the presence of air gaseous mixture, suspended particle, and some water vapor. So you are finding the almost 3/4, that mean nearly 75%, as I said in the last slide, that 75% of this total mass, which is within 11 kilometers of the surface. within 11 kilometer of the surface means above the sea level in the atmosphere within 10 to 12 kilometers, you can find nearly 75% of this total mass is confined, and that is actually within troposphere zone. Why it is so? Because by gravitational pull, actually, you understand that it is generally the maximum amount of the atmosphere which is enveloping the Earth crust within 10 to 12 kilometers above the sea level within altitude of the atmosphere. Hello, it is clear?
Yes, sir.
Yes, sir.
Okay, fine.
Yes, sir.
So therefore, you are finding the Earth's atmosphere is characterized by variation of temperature and pressure with height also. Normally, you will expect that generally with the increase in pressure in the atmosphere, that means with the altitude or height above the sea level in the atmosphere, it is obvious the pressure decreases. It is obvious because whatever the total amount of the atmosphere, mass of the atmosphere, because of the gravitational pull, you are finding within 10 to 12 kilometers above the sea level. So naturally, as we move more and more in the upper direction, you can find the pressure decreases with altitude in the atmosphere, as you find the amount of atmosphere decreases. As you know that to some extent, it is within 100 kilometers above the sea level, almost 99%. Then you find above 200 kilometers above the sea level, actually you find the almost thin out, means the level of atmosphere almost I would say non-existent, and above the 500 kilometer, it in fact the exosphere begins. So therefore, you understand why pressure decreases with altitude in the atmosphere. And at the same time, we will see the temperature variation in the atmosphere, and that's why we say temperature profile. And on the basis of the temperature profile, generally you are having we could say the structure of the atmosphere. And again, generally atmosphere, it can be further divided into some horizontal segment above the sea level with certain height or altitude on the basis of temperature profile, and that we will discuss shortly. And then you see, in fact, the variation of the average temperature profile with altitude is the basis for distinguishing the layers of the atmosphere. So therefore, you are finding the structure of the atmosphere is simply based on the temperature profile or due to variation in the temperature. In this context, I would like to tell you one important thing. Just a moment. Let me check the next slide. Okay. Before that, I would like to say that the temperature profile, you will see the one term very commonly, lapse rate. Lapse rate means actually the temperature decreases with altitude. Generally, lapse rate we represent by minus dt by dz. Okay, differential actually dt. That means small change difference in the temperature by dz, where T actually capital T, that is the temperature in Kelvin, and Z actually that is the represent the altitude or height in the atmosphere. Minus Y, because we are considering the lapse rate means really the decrease in temperature with altitude in the atmosphere. And in this context, I would like to tell you that what's the difference in degree Celsius, that is going to be the same as difference in Kelvin. Why it is so? Because as you know that whenever we are converting degree Celsius into Kelvin, you know the 0 Kelvin means minus 273.15 degrees Celsius. So naturally, any degree Celsius we are converting into Kelvin, we are adding plus 273 roughly. Okay, and then similarly from Kelvin, when you are converting into degree Celsius, we are just simply subtracting the minus 273. By that, we are converting from Kelvin to degree Celsius. So normally in chemistry, whenever we are dealing finally with respect to Kelvin, okay, and that is you find that is absolute scale. And here, so it is obvious the difference of degree Celsius. Suppose I am saying that the final temperature minus initial temperature. Suppose final temperature some degree Celsius. So you are converting into Kelvin. So plus 273. Similarly, you are finding the initial temperature that was in degree Celsius, and now you are suppose you are saying the degree Celsius and plus 273, that is converting into Kelvin. So naturally, you understand that the difference of degree Celsius ultimately it gives you the difference of the Kelvin. But you don't confuse with that degree Celsius and the degree Kelvin is same, because you know the difference is 1 degree Celsius is nearly equal to 273 Kelvin. So always you remember however the difference in degree Celsius is the same as difference in Kelvin also. Okay. For example, I'm telling you that when you will find the Earth model surface temperature is suppose 255 Kelvin. Okay, and whereas the Earth surface temperature in actual 288 Kelvin. Now 288 Kelvin minus 255 Kelvin. So naturally you say 33 Kelvin. Actually that also you can say 33 degrees Celsius, because what's the difference in Kelvin, and that's the same as what's the difference in degree Celsius. Hello, it is clear, understandable?
Yes,
Yes,
sir.
sir.
Yes, sir.
Now you see what's the left side we have said the minus dt by dj, the minus sign indicate the change in temperature, okay, in atmosphere with altitude, and that actually decreases. So therefore the left side, when you are saying positive left side, that means actually the change in temperature with altitude decreases. On the other hand, when you see the reverse thing, that instead of decreasing temperature with altitude, rather it increases, then you are saying actually the negative left side. So always you remember that. You don't get confused. That whenever we say the positive left side, that means left side itself it indicates the decrease in temperature with altitude. The positive left side means it is happening in that way, that the temperature decreases with altitude. But on the other hand, the moment you are saying that instead the temperature increases with altitude, that is actually opposite to the concept of the left side. So naturally that you are saying negative left side also. And later on you will go through, that is, one is the ideal case DALR, that means dry adiabatic left side, and another is normally you will find which happens in actual in terms of wet adiabatic left side, ambient left side, then you can find the atmospheric left side, etc. Okay, that always going to be less than that of the dry adiabatic left side under ideal condition also. Hello, am I audible? Okay.
Yes, sir.
Yes,
Okay.
sir.
So therefore, you just see here, on the basis of this temperature profile, if you look at here, the y-axis, it represents the height or altitude in the atmosphere, which begins from the above the sea level. Okay, generally sea level we are considering on the Earth's surface 0 Kelvin, and as far as x-axis, it is in given the values of suppose in degree Celsius as well as degree Fahrenheit. If you look at here, suppose the actually origin it is considered in terms of degree Celsius minus 100 degrees Celsius, and as far as the sea level 0 Kelvin, sorry, 0 kilometer. Okay, then you can finding that 10, 20, 30, 40, 50 in this way it is in kilometer above the sea level. And as far as in degree Celsius, you can understand that minus 100 degrees Celsius means actually 173 Kelvin. Similarly, minus 80 degrees Celsius, minus 60, then minus 40, and you just see the nearly minus 20, and then you are finding nearly 20. So as I have already said, that the Earth's surface temperature is the 15 degrees Celsius. So 15 plus 273 means 288 Kelvin. Okay, so here you are finding that it has shown approximately here, it is not to the scale, that 293 Kelvin. Okay, like that. And you just see, if you see on the basis of the temperature profile, the broadly the classification of the horizontal segment of this atmosphere on the basis of the temperature profile, first we are finding troposphere, then above that we are finding stratosphere, above that we are finding mesosphere, above that we are finding thermosphere or ionosphere, and above that we will find exosphere also. Here up to 110 to 120 kilometers above the sea level it has shown. And if you see the in terms of the pressure, as you find the what's the pressure you are finding in millibar actually at 20 kilometer height, then you are finding at 30 kilometer height it is going to be 1 millibar. Okay, and whereas at 40 kilometer height it is finding 0.1 millibar. So it is understandable that with altitude or with height in the atmosphere the pressure decreases.
That's sir mile, sir. Mi, sir. 40 mi, sir. 30 mi, sir.
What I'm saying, actually this is nothing but actually in terms of the correspondingly, you just look at here, the 30, this is 40. Okay, actually you are saying this is representing in terms of the millibar. Okay, millibar corresponding to that. Hello, corresponding
yes,
to millibar actually. Okay.
No, sir. I'm saying the 30 and sir, the 40 are in the miles, sir. In the unit distance.
Oh,
unit
this one on the right hand side. Yeah.
Yes.
So that's why you are finding that in terms of suppose between 20 to 30, that is miles. That you can say. Yes. On the right hand side, the 20, 30, 40, 50, 60, 70. Is it so? You are saying?
Yes, sir.
Yeah, that you can say. But I'm trying to follow actually in terms of the kilometer. Okay, so naturally you are saying the 10 millibar, so you are finding that is nearly around 25 to 30 kilometer. Actually, you are finding that is a 10 millibar, and with respect to mile. Okay, generally you know that the kilometer is less than the mile. Okay, you will always find, because generally almost more than 70 to 80% actually miles are going to be the kilometer also. Okay, that means kilometer is going to be, are you getting my point? The miles are going to be always lower than the kilometer. Is it clear? Hello.
Yes, sir.
So therefore here you are finding that with respect to suppose a 30 kilometer, that is the 10 millibar, then you are finding nearly at the 48 kilometer, you are finding 1 millibar, then 0.1 millibar, then 0.01 millibar, and 0.001 millibar. And on the right hand side, what is given, that might be in miles also. Okay. Is it clear? Understandable? Now look at here. As far as the lapse rate is concerned, as we understand that from nearly, it is not exactly actually 20 degrees Celsius, you will find it is in the range of, generally I am telling you, 15 to 18 degrees Celsius. Okay, roughly. So naturally you can find 288 to 290 Kelvin. Okay. And here from 288 to 290 Kelvin, if you see, the temperature decreases with altitude. Okay, up to suppose the 11 kilometer it is shown, that means here you are finding positive lapse rate, and up to what the temperature decreases, you will find nearly 56 degrees Celsius, minus 56 degrees Celsius. So that's why you look at here, nearly the minus 56, the minus 60, and nearly minus 56 degrees Celsius also. And after that you are finding pause, that means stop, where you are finding the isotherm. And that's why you are finding that between 12 to almost you can say nearly that up to 15 to 18 kilometer, you can find that the tropopause, where there is, or isotherm rather, there is no change in temperature. This is not actually exactly to the scale. Okay, and then you are finding the stratosphere zone. So on an average, you are finding after 12 kilometers above the sea level, the stratosphere begins, and generally it is within the range of maximum the 45 to maximum 50 kilometers. And here on the other hand, you find that is actually the negative lapse rate, where you are finding the increase in temperature with the stratosphere zone. And that is because of the ozone layer, stratospheric ozone layer. As you know, it absorbs the ultraviolet radiation. And here you see the temperature normally you will find increases from minus 56 degrees Celsius to minus 2 degrees Celsius. Suppose with respect to this, if you draw here, you look at here, the minus 20, then it is coming 0. So nearly it is coming near to 0. So that means minus 2 degrees Celsius normally you will find. Okay. And then you are finding the stratopause. The stratopause means the isotherm, the some kilometer, okay, above that stratosphere. That means always you will find tropopause means that the pause between troposphere and stratosphere, and the stratopause means it is between the stratosphere and the mesosphere. Yes, that is also isotherm you are finding. And here once again you are finding that is the positive lapse rate, temperature decreases with altitude. Maybe it is not exactly near to the almost near to the scale, or you can say that here generally you find the temperature decreases from minus 2 degrees Celsius to the extent of minus 90 degrees Celsius or so, even little bit higher maybe, it is possible. And then again you can find some isotherm nearly, and that is called actually mesopause, and it is basically not the tropopause. Okay, that is the tropopause. Actually you will find this one, that is the actually printing mistake. So you will find rather, because I have taken from the some online internet actually that is being projected, and from there only. And here you will find rather the basically the mesopause, and here you are finding that is between mesosphere and thermosphere. Okay. And then here you are finding from minus 90 degrees Celsius to near about plus 1200 degrees Celsius. Just imagine plus 1200 degrees Celsius. It is increasing, and that is known as thermosphere or ionosphere. And generally, you are finding that the troposphere is within 11 to 12 kilometers. Then you are finding stratosphere within 40 to 45 kilometers, and nearly 45 kilometers. And then you are finding above that nearly within 85 to 90 kilometers, that is mesosphere. And then you are finding thermosphere begin and ionosphere. And generally, up to 200 kilometers, there will be some very, very thinning existence of atmosphere. And then above that you will find that the presence of the atmosphere decreases, and above 500 kilometers almost exosphere begins. And then you will find the up to 2000 kilometers you will find in terms of that. And after that you are finding plasmosphere, then magnetosphere, etc. also. Okay, but these are the broadly classification of the atmosphere. So this is understandable? Hello?
Yes, sir.
Okay. Now again, this troposphere, again in this troposphere, you will find it is variable, not only with respect to the height, also you will find what's the troposphere height during summer, during winter, the troposphere zone actually generally, the height generally decrease. So it is little bit variable as far as the troposphere zone. Because why? Because within the troposphere, you are finding there is a lot of turbulence, lot of unstable atmosphere. Here you will find a lot of vertical movement of the air mixture in the upward direction. Okay, and where the stratosphere very you will find calm, quiet, stable zone, where you will find rather the horizontal direction, the movement of the atmosphere instead of the vertical motion. Again, in the mesosphere, it becomes a little bit unstable or so. Okay, and here you can find the troposphere actually during winter is expected to be a little bit smaller height than that of the summer also. Okay, whether this is understandable to some extent? Clear?
Yes, sir.
Yes,
Okay, fine.
sir.
Yes, sir.
Fine. Quickly. Look at here. So therefore, you are finding the lowest layer of the atmosphere. The same thing actually you are finding. You just see here in the pressure millibar. You are considering at the zero level. You are finding suppose 10 to the power 3. Then you are finding 10 to the power 2. Then 10, 1, 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3, and then you are finding 10 to the power minus 4. And on the left hand side, you are finding altitude in kilometer, and the temperature, it is being shown from minus 100 to that. You just see here, look at here, the nearly, as I said, that not 20 exactly, you will find nearly 15 to 18 degrees Celsius maximum actually. Okay, so from here you find the troposphere zone begins, and then you find the tropopause, then stratosphere. You are finding near about 45 to 50 kilometers. Then you are finding isotherm, then you are finding mesosphere, it is going above 80, near about 85, and you are finding 85 to almost 90, it is going to be isotherm, and then again you are finding thermosphere begins also. And you are finding in the upward direction the pressure decreases, and what is giving on the right hand side in millibar. So therefore here you are finding the lowest part of the layer of the atmosphere extending from the Earth's surface up to tropopause, which is at 10 to 15 kilometer altitude. And generally also the shape of the Earth's surface is different. You will find generally equatorial as it is bulge. So naturally you are finding troposphere zone is going to be little bit higher length, actual altitude than the pole region. And therefore you are finding that depending on the latitude and the time of your year, you know, the latitude means higher near equator and lower towards poles, and time of the year means generally what will be the length of the troposphere during summer, during actually winter it becomes shorter. So therefore you are finding the characterized by decreasing temperature with height. Rapid vertical mixing, as I have said, the rapid vertical mixing, that's why it is very, very unstable, because here you are finding the atmosphere is there mainly by the pull of gravitational force or so. And then you find the stratosphere extend from the tropopause to stratopause, actually the region from 45 to 55 kilometer altitude, temperature increases with altitude. So therefore you are finding in the stratosphere there will be permanent temperature inversion. That means their temperature increases with altitude, and that is actually negative Black set. But I would like to remind you in this regard, in the troposphere also we observe some temperature inversion, and that is temporary. And you will see the temperature inversion, that is the extreme stable case of the atmosphere. As we are saying repeatedly, the stratosphere is the extreme stable case of the atmosphere, the permanent temperature inversion, and that temperature inversion even we observe within the troposphere zone also. And where you find that with the decrease in temperature, with altitude, then you will find a layer of atmosphere which have the higher temperature, and then again above that you will find decrease in temperature with altitude within the troposphere itself. Okay, and temperature inversion actually causes more air pollution near the Earth's surface. Then you find the mesosphere extends from the stratopause to mesopause from 80 to 90 kilometer altitude, and temperature decreases with altitude to the mesopause, and which is the coldest point in the atmosphere. Okay, that you will find. And quickly, just I will cover up to this only today because I don't have any other time actually. I have to go for the next step. So as per the composition of the atmosphere, if we consider hello,
Sir, can you repeat again where we can find the temperature inversion?
Why we find the temperature inversion?
Yes, sir.
Yeah.
In which
You will find in the stratosphere zone there will be the permanent temperature inversion because of actually ozone layer. The ozone layer actually can absorb the ultraviolet radiation, and there will be continuous breaking and the formation of ozone between the oxygen molecule and the atomic oxygen. And due to that, the stratosphere zone generally it is having increase in temperature and permanent temperature inversion also. Okay.
Okay, sir.
And here you see the composition of the, and that's the reason that because of the stratospheric ozone layer, we observe in the stratosphere the permanent temperature inversion. Now you see the composition of the atmosphere, as we have already mentioned, in terms of the concentration of the gases in normal dry air. Look at here, nitrogen you are finding in ppm here, so that means nearly 78% by volume. Then you are finding oxygen nearly 21% by volume. Then argon you are finding nearly actually 0.93% by volume, or nearly 1%. And whereas the carbon dioxide earlier it was nearly 0.033% by volume, or rather 330 ppm, but these days you can find it is hovering around 390 to 400 ppm. Okay. Then you find the presence of other noble gases as well. And other than this, just a moment quickly. Other than this, you will find the presence of the water vapor, as well as the you will find, suppose the water vapor may exist between within the range of 1 to 3% by volume in the atmosphere separately, and always you will find near the sea level the water vapor is maximum as we move in the upward direction. Suppose if, for example, if I say if the presence of water vapor near the sea level at 0 Kelvin is 1%, then at a height of 8 kilometers above the sea level it is going to be 0.05%. Just imagine. Okay. And along with that you will also find the presence of very finely suspended particle, fine suspended particle. The particulate matter you will find earlier we used to consider less than less than equal to actually 10 micrometer, then less than equal to 5 micrometer, and rather this day we are concerned about the less than equal to 2.5 micrometer, because the more finer, the more remains suspended in the atmosphere and more we inhale actually, and which with different, along with the toxic materials, gaseous substances, etc., other toxic material which we inhale and generally deposit on our respiratory tract as well as the lungs also. Okay, so that in due course we will study further also. Okay. Here I have nothing to say at this moment, but you just look at here. Okay. Hello, this screen is visible. Hello.
Yes, sir.
Yes, sir.
Here you can find
Yes,
what's we have discussed actually. Beside that, the water vapor also it is a dry atmospheric composition will be present. So here you can find the permanent and variable gases. So what's a dry gases mixture? These gases that form a constant portion of the atmospheric mass. And other than you can find the variable gases of the atmosphere, water vapor, carbon dioxide, ozone, etc. that we will do in due course of time also. Okay. So I think that today we should stop here. Okay, up to this, and that's a problem. We are having very less opportunity, but simultaneously I will also send your study material, and you please try to complete the assignment and submit on or before actually. What's the time I've given? 24th or 25th? What's the time I've given?
24.
24.
24.
Okay, so by 24th you must submit it. Okay, because this is a MCQ format I have given, because on the very just hardly 1 or 2 classes you are doing, so I cannot give too much pressure. Just to understand the things, what we are going to through it also. So that's why. Okay, is it clear? So
Yes.
Yes.
you can we can leave the class and have a good day.
হ্যালো স্যার, হ্যালো।
Yes, 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 yes.
হ্যাঁ স্যার, সাগ্নিক রোল নাম্বার 64 সকালে যখন অ্যাটেন্ডেন্স নিচ্ছিলেন তখন আমার ইন্টারনেট ছিল না।